Every time your device connects to a network, it somehow gets an IP address. But here's the interesting part. It starts with no IP at all. So how does it even communicate? Let's walk through exactly what happens, packet by packet, using DHCP. The process starts with a broadcast called DHCP discover. Since the client has no IP yet, it sends source IP 0.0.0.0 and destination IP 255.255.255.255. Essentially saying, is there any DHCP server out there that can give me an IP address? Inside the packet, you'll see a transaction ID to track the exchange, the client's MAC address, and a parameter request list asking for things like DNS, gateway, and subnet mask. One or more DHCP servers respond with a DHCP offer. Each server proposes an IP address, subnet mask, default gateway, DNS servers, and a lease time. This IP is placed in a field called yiaddr, meaning your IP address. At this stage, the address is only reserved, not fully assigned. The client may receive multiple offers, but it must choose one. It sends a DHCP request, again ASA broadcast. This message includes the selected IP address and the server identifier. Broadcasting this is important. It tells all other servers, I've made my choice, withdraw your offers. The selected server responds with a DHCP acknowledgment. This confirms the IP address, lease duration, and all configuration parameters. At this point, the client can finally configure its interface and start communicating. Before actually using the IP, many clients perform a quick IRP check to ensure the address isn't already in use. If a conflict is detected, the client sends a DHCP decline and the process starts again. DHCP doesn't just assign an IP, it manages it over time. At around 50% of the lease, the client tries to renew it using a unicast request. If that fails, it later broadcasts again, allowing any server to respond. All of this initially happens using broadcasts, which means DHCP typically works only within a local network. If the server is in another subnet, a DHCP relay is required. The relay forwards the request and adds information about the client's network, so the server can assign the correct IP range. So the next time your device connects to a network, remember, it starts with no identity and negotiates one through a series of structured exchanges. And all of this happens in just a few milliseconds. If you're curious about how systems really work behind the scenes, consider subscribing. We break it down step by step.